Assalamualaikum and good day to everyone. Today we continue to our new lecture on topic moment of a couple. What is the moment of a couple? Okay, let's refer to this figure. The moment of a couple is defined as we have two parallel forces with the same magnitude but opposite in direction, separated by a perpendicular distance d. So, based on this figure, by using scalar analysis, moment at point O is equal to force times distance. And this figure, moment at the point O is equal to R cross F. By using vector analysis, means that R is the any position vector from the line of action F. This is the R. So means that the moment couple is equal to F times distance for the scalar, and moment is equal to R cross F is for the vector analysis. So number 1, the resultant force is equal to 0, and then it is tendency to rotate in specified direction. Couple moment is a free vector, and also it can be computed by any point because it's a free vector. And then choose the line action of one of the force in the couple. Means that for this example, this figure, we have RB and RA. So you can choose either one. And then the last one, a resultant couple moment is equal to sum of the couple moment of the system. Means that moment resultant couple is equal to M1 plus M2. For this example, we have this figure. For this figure, we have that the net external effect of couple is that the net force equals 0 and the magnitude of the net moment is equal to force times distance. But here this figure shows since the moment of couple depends only on the distance between the forces, the moment of a couple is free vector. So this means the free vector. And then this figure means that it can be moved anywhere on the body and have the same external effect on the free body. So this one we have moment couple 1, this one is moment couple 2, and this is the moment resultant. So that is why moment resultant of couple is equal to M1 plus M2. For the application, moment of couple, based on the figure, this is figure 1, this is figure 2. So what is the difference here? So we have two parallel forces with magnitude 30 Newton and separated by the distance is 0.4. Okay, let's refer to the figure 2. Figure 2, we have two parallel forces with the magnitude 40 Newton separated by the 0.3 distance. So here, a torque or moment of 12 Newton dot meter is required to rotate the wheel. Figure 1, 30 times 0.4 is 12 Newton dot meter, and figure 2, 40 times 0.3 is also 12 Newton dot meter. So, why does one of the two grip of the wheel above require less force to rotate the wheel? Figure 1 require less force than figure 2. Why? It is because figure 1 has larger distance than figure 2. That is why figure 1 has lesser force compared to figure 2. And then, when you grip a vehicle steering wheel with both hands and turn, a couple moment is applied to the wheel. You can see this photo. We have two parallel forces here. One is positive, one is negative. Will older vehicle without power steering have neither larger or small steering wheel? So the older vehicles without power steering have neither larger or smaller steering. Definitely they have larger. Okay, let's do this example 4.15. Okay, let's read the question. Two couples act on the beam with the geometry shown. Determine the magnitude of F so that the resultant couple moment is 1.5 kN/meter clockwise. First, we need to analyze what is the information given. So here we can see, based on the figure, we have two parallel forces F. So we have F and another F is given 2 kilonewton is horizontal. Okay. So the vertical F, we need to find out what is the value. And then the question also give us resultant couple moment is 1.5 kilonewton clockwise. So what is the meaning is? The meaning is the moment resultant. Moment resultant means that we have two parallel forces. So this parallel forces will create M1 and M2. And then this moment couple is given 1.5 clockwise. Clockwise means negative. That is the meanings of this information. So in order to get what is the magnitude of this F, what we should do? So the first one, we need to have the summation moment resultant. So the summation moment resultant is equal to, so based on this figure, we have this positive F and we have this negative F. So which one? Which one we going to take? So let's say we take moment created by the force time distance. So summation moment here is equal to this F times this distance. So negative F times 0.9 plus. So here we have to choose this horizontal 2 kilonewton of this one negative. So we choose this one. So the distance is 0.3. So we have plus 2 times 0.3. So here we have the resultant couple moment is equal to negative 0.9 F plus 0.6. And then the value of the resultant couple moment is negative 1.5. So we can solve what is the F. So by solving F, so we get F is equal to 2.33 kilonewton. Alright, let's go to the second example. So this example is 2D or 3D. So we have 3D here. 3D. So let's read the question. A 450 Newton force couple. Couples means we have two. So we have FA and we have FB. Acting on part as shown, determine the couple moment in Cartesian vector. So for this case is a 3D. So moment is equal to R cross F. So what is the R here? R is given from A to B. R A to B. So we have R A B. And then which F we want to choose. So we're going to choose FB here. So we need to write in the matrix. Before that, is it our F here is already in Cartesian or not? So you need to get what is the FB. So we need to solve the FB in Cartesian. So here we have RAB. So RAB lies in the x-axis. So that means RAB is 0.4 I. Unit is meter. And then FB. FB we need to resolve in Cartesian. So we have FB here is 450. So take a look. FB lies in what axis? So this one is Z. And then we have Y. So that means we have 0 I. So we have here J and K. So you can resolve in J 450 times 4 over 5, and then we have negative 450 times 3 over 5 for K. So because of the forces is coplanar in Z axis and also in Y. So Y is a positive J. So we can solve. So we get FP is 0I plus 360 J minus 270 kN. So we can write in metric form like this. So M is equal to RAB cross FB. So you write I, J, K, and then we substitute the R, and then we substitute the F. So you can solve as usual. So you can determine the resultant couple moment is equal to 0I plus 108J plus 1.4K. And then we move to the next example, 4.17. So this 4.17, we have two couples act on the beam with the geometry show. So the D here is given 4 feet. Okay. So now we have two parallel forces here. This is the coplanar. So what we should do if we have coplanar, we need to resolve into the vertical and also horizontal. So based on this vertical and horizontal, you need to choose which force you want to use. Which force can create moment. So the distance is 3. So the distance is 3. So definitely we can choose the vertical forces, right? Vertical forces. So you need to determine what is the value for the vertical forces. And then for this one you need to resolve to the horizontal, vertical and horizontal. So based on this fig, based on the distance, which force will create moment? So we can get the horizontal, right? So here you need to determine the horizontal value, horizontal force value, as usual. So this is the answer. Right? Okay. So the resultant couple moment is equal to negative 43.3 times 3. Okay, from this vertical, and then plus with the 64 times 4. 64 times 4. So this one lah, this horizontal. So we can have the resultant couple moment is equal to 126 feet dot pound counterclockwise. Okay, the last example is a 3D. So now we have two forces here. So we need to determine what is the couple moment acting on the pipe. So here we have two forces. So you need to determine which force we want to use. Is it negative one or positive? And okay, so the moment is equal to R cross F. So what is the R? So we define R. R is the RAB. So what is the RAB here? And then the F we choose positive S. So this is our moment lah. So this unit is mm. So we need to change to meter. So you can determine the RAB and then you can write the force. So now the force is only acting K. So means that R is 0, J also 0. R is 0, J is also 0. So you can write, you can get what is the RAB, you can F. So you can write into the metric form. Then you can solve. So the resultant couple moment is equal to 40I negative 8J Newton dot meter. Alright. So what is the outcome of our lecture today? So I hope everyone understand what is the moment of couple, and then you can calculate what is the moment of couple, and also you can calculate the moment of couple in 2D using scalar, and also in 3D by using the vector analysis. So and then you can calculate what is the moment resultant couple moment. Alright, that's all. See you in the next lecture. Bye.